In this video, we're going to talk about how to find the domain if we're given the equation. So think about again what this word domain represents. It means what are all the numbers that you can use for x? So what are all the numbers you are allowed to use for x? Okay. So if we take a look at this example right here, f of x equals 3x squared minus 5. So I have the graph here, so you can look at it left to right, but the graph wouldn't be here. So let's ignore the graph for a second. And we have to think about what numbers can we plug in for x and be able to square it, then multiply by 3 and subtract 5. So the first thing is think about negative numbers. Can I plug in for x a negative number? So can I put -8, for instance, here? And then multiply it by 3 and then subtract 5. So negatives are okay. I can square negatives. I can also square positives. So I could put, for example, 5 in for x. I could square 0. I could do 0 squared times 3 minus 5. So 0 would work, negatives would work, positives would work, fractions would work. I could put 1/3 in and square it, and then multiply by 3, and then subtract 5. Okay? So the point is, any number can go in for x. You can square and multiply by 3 and subtract 5 to any real number. So if the equation does not have a fraction with a variable in the denominator or one of these symbols, you're going to find in this lesson, the functions we're dealing with, that the domain is going to be all real numbers. So in interval notation, it's written like this. So the domain for this problem is all real numbers. Okay, so now I graph this. So I went to the graphing calculator and I said graph 3x squared minus 5. So here's the graph of that. So if we double check it, if we go left to right, you could see that this graph keeps going and going and going on the left, and it keeps going and going on the right. So it matches what we got by just thinking about it. What numbers, because that's what x is, numbers that go in for x. All numbers can go into x for x. So here's a couple other examples that have the domain all real numbers. So for example, y equals 4x minus 3. I could plug in any number for x there. Here's another example. 3x squared minus 5x plus 4. I could plug any number in for x here and here, any kind of number. Okay, so here's two more examples that have the same answer for the domain. Okay, now let's talk about if the equation, the function, has a fraction bar. So again, the best way to do these, instead of thinking you have to memorize, is just think. Think about what you know about your previous math classes. If you have a fraction, so if we have a 4 on the top in the numerator, what number, when you have a fraction, can the denominator never be? So hopefully you remember that, like, for example, if I put in the denominator a 5, no problem, right? It has an answer. But if I go put in the denominator, in the denominator a 0, we have an issue. You can't have 0 in the denominator. Can never have 0 in the denominator. So whenever you have an equation that has a fraction where it has a variable in the denominator, you need to set the denominator equal to 0 and solve it. Find out what number x cannot equal because it would make the denominator contain a 0. So the denominator cannot equal 0, or else we call that undefined in math. So we can't have this. Can't divide by 0. It's okay if 0's first. If 0's on the top, it's okay. But not in the denominator. I remember it like this. This looks like the word under almost. So 0 can't be under because then it's called undefined. And also you'll have a calculator. So if you forget that 0 can't go second, you could always check it. And you could see 0 on the top is okay in the numerator. Okay, so it says find the domain. So if I was going to make a table and plug numbers in for x, I could plug in 7. If I put 7 right here, I would get 4 over 7 plus 7 is 14. I have to find what number is going to make this denominator here 0. The denominator cannot be 0. So I need to solve this. And now I know the number that x can't be is -7. So x cannot be -7. So in my own words, what is the domain? X can be any number, just not -7. Now it doesn't say use your own words. It says use interval notation. So interval notation is where we go, we have to look at a number line and we go left to right. So I'm going to graph this real quick to make a visual for us. So it's saying x cannot be -7. So this number right here, if I put -7 in for x, I'm in trouble because -7 plus 7 would put a 0 there. Can't have that. So this is the number x can't be, but it can be any other number. That's the bad number that x can't be. So now if I want to write my answer in interval notation, which that's what it asks us to here, I go from the left to the right. So it's going infinitely left, so x can be any number over here, but not -7. So that's what this parenthesis means, not included. So it could be any number over here, but not -7. And then we have a spot where there's no shading. So that's when we put this symbol into the problem. And then any number greater than -7 are okay for x. So that would be our answer for interval notation. So again, to recap, if I had the equation 3x squared minus 5, this problem, the domain, is all real numbers. I could plug any number in for x here. But if I have a problem that looks like this, we have an issue. The denominator can't be 0. So you have to think about what number, if I put it in here, will make this 0. The top, it doesn't matter. The top can be any number. So we would set this equal or can't equal 0. So that way we can find the bad number. So x cannot be 4. If you put a 4 here and a 4 here, we would get 8. 2 times 4 is 8, plus 5 is 13 on the top, which is totally cool. But then here we would have 2 times 4 is 8, and 8 minus 8, oh no. So this is the bad number. It could be any number but this. So again, here's our two cases. All real numbers when it looks like this. When it's a fraction, we have to solve the problem in the denominator, not the numerator. The numerator is okay. So now if we look at the graph, so I graphed this equation here and I graphed it, you could see it matches the answer that we got here. The graph is going infinitely here to the left, so it keeps going and going and going. And then it approaches, here's -5, -6, -7. It's getting closer and closer, but it's never going to have a point here. It's going to get really close, but never have an ordered pair at -7. And then we have the union because there's some space right here. And then this one here is approaching, it's getting closer and closer to -7. And then it's going infinitely on and on. So the picture of the graph, when I put this in my graphing calculator, this function, matches what we got by just thinking about what x can't be. So that's what you're going to do with these ones that are equations. Just think about what you know about your math and what's allowed. So the next type of function we're going to talk about in this lesson is if the function has a square root here where there's not a number right here, it's just a square root. Okay, so when you see this symbol right here, when there's no number here, it's like a 2. So it's asking you, in case you've never seen this symbol, let's say there was a 4 inside, it's asking you what times itself makes the number in the inside. So in this case, it would be 2. Okay, so let's think about something. So the square root of 9, what times itself is 9? 3. Square root of 0, what times itself is 0? 0. Square root of 16, what times itself is 16? 4. But what if we put a negative inside? What times itself is -4? So 2 times 2 doesn't work. -2 times -2, these are both 4. There's no way to get an answer when you put a negative inside this symbol. So because that's not possible, we have to figure out what number would make this negative. 0 is okay. We're okay with 0. But we want the number inside the radical to be a number that's bigger than 0, right? Think about it for a second. Aren't numbers bigger than 0 positive? Exactly. So that is why we are going to set the expression inside the radical greater than or equal to 0. And then we're going to solve that inequality. And the reason why we do that is because you can't square root a negative number. You can't do that to get a real number. And that's the type of numbers we can graph. So it says find the domain. So you're going to take whatever's inside. So 2x minus 4. And it has to be a number greater. The mouth should be going to it. This number here needs to be greater than or equal to 0. So it has to be a number bigger than 0 or equal to. So now we're going to solve this. So we're going to add 4 to both sides. Then divide by 2. And in my own words, the numbers that can go into this spot for x has to be greater than or equal to 2. So let's make sure we understand what that means. So here's our original problem. And we're saying that this is the domain. So any number, including 2, that's what this line means, so 2. So if I put 2 in right here, I would get 2 times 2 is 4 minus 4 is 0. And the square root of 0, that's cool. We can do that. Square root of 0 has an answer. It's 0. Okay, so then we could pick any number greater than or equal to 2. So for example, I could pick the number 3, right? It's greater than 2. So now if I plug in 3 for x, so right here I'm going to plug in a 3. So if I plug in a 3, I'd have 2 times 3 is 6. And then 6 minus 4 is 2. So the square root of 2, what times itself is 2? It's going to be a decimal number. So if I take 1.4 times 1.4, should be about 2. Close to it. Yeah, it's close. So it's about 1.96. But the point is, it didn't say can't, like when we had this, it said we can't have that, right? So we can't have, with radicals, we can't have a negative inside the radical. And that's how we'll know. So we have to find the numbers that when you plug them into the x spot are going to work. So if we plug a number in, like for example 1. If I plug in 1, is 1 greater than or equal to 2? No. So let's see what happens when I plug in 1 for x. So when I plug in a 1 for x, we'll get 2 times 1 is 2, and 2 minus 4 is negative 2. So when I plug in 1 for x, we get negative 2, and we can't have that. No. That's what domain is telling us. It's telling us the numbers you could use for x. This is important, especially when you graph, because you have to pick the right numbers to plug in so you can get the output and be able to graph the function. So you have to be smart about the numbers that you're picking. Okay, so if we go back to this is again in my own words, pick any number that is greater than or equal to 2. But it's asking us to practice interval notation. So I'm going to do a quick graph of this. So it says equal to, so I'm going to use a bracket. Any number greater than or equal to 2. So now when I write my interval notation, I always go from the left to the right. So x can be 2 and anything greater. That's the number. Those are the numbers I could put in for x. Now here's the graph. So if I type this in my graphing calculator, it makes this graph right here. So if I go left to right, do you guys see that it's starting here on the x-axis at 2? And then it keeps going and going and going. So it matches what we learned in the previous lesson for domain when you're given graphs. Look at the next example here. So it says, find the domain, write your answer in interval notation. So when we look at this problem, we're trying to think of what numbers can go in the x spots. Okay, so we know that x can be any number on the top. But in the denominator of a fraction can never be 0. So now we would solve this. And when we solve it, we find the bad number, the number that x can't be. Because if x is 2, it's going to make 0 at the bottom. So in my own words, x can be any number, not 2. But it doesn't say to use my own words. It says interval notation. So I'm going to draw a quick sketch. So it can't be 2, but it can be any other number. So when I write my interval notation, I'm going to go from the left. It's going infinitely left. It stops here at 2, union, and then it keeps going, any number greater than 2. So that would be my domain if I need to write it in interval notation. Okay, let's take a look at example 5. So here it's asking us, what number can I plug in for all the x spots? So I can plug in, this is a polynomial here, I can plug in any number for x and raise it to the 4th power, multiply by 5, multiply it by 10. So this is going to be all real numbers because we don't have any issues, we don't have any constraints or anything like that. Okay, now example 6, we have a radical. This number here can be any number. This number here can be any number. The problem is the number that's in the radical. So the minus 3x and the 4 are not in the radical. It's on the outside. So we ignore those because this can be any number. This could represent a negative and we're cool. But the 5x minus 15 is in a dangerous position. It's in the radical and it has to be greater than or equal to 0. The number in this radical has to be positive or we'll get an error. So now we're going to solve this. So we're going to add 15 to both sides. And then divide by 5. And we get that x is greater than or equal to 3. So in my own words, I could plug in here and here any number as long as it's greater than or equal to 3. So we need to write our answer in interval notation. So I'm going to go ahead and draw a picture to help me. X has to be a number that's greater than or equal to 3. So as an interval, it would look like this. Left to right. Any number including 3 can go in, and greater than can go in for X and won't make an error.